Good afternoon, everyone. My name is Joshua Robinette, and I'm excited to introduce to you today a MATLAB program that I created at Embry-Riddle as part of the undergraduate research program I'm proud to be a part of. I was working with Dr. Yue Zhou and Amir Ya, my mentor, and as part of a paper that we were working on together, I was able to create this MATLAB program to analyze porosity of some binder jetted green parts that we were trying to analyze. So this is the program I'd like to present to you today. I was relatively new to MATLAB at the time, but I was able to create this program and it proved to be a really great learning experience for me. And so I've posted it to GitHub and I'm going to share a hands-on tutorial on how to use it here. I will post the link to GitHub, the GitHub file in the description. And without further ado, let's get started. Okay, so to start, we're going to run the program. And what we need to do at the very beginning is we need to get the name of the image we're going to use. So for this MATLAB program, it's currently in my downloads folder. And in order to get the image to register with the program, has to be in the same folder as the MATLAB program. So I have an image in the downloads folder, and I can pull that up here. This is in the quick access. You can see it here as well. And what we have here is an image called test image 1. And it's a JPEG file that's necessary for this program. And you can see at the end of the name it has a 1. That's because for each image I had a total of 32. I would just name them the same thing and then add a number at the end. And that allowed me to create workflow that could analyze each image in series, as you'll see in a couple minutes. So again, I'm going to put in, I believe the image name was test image. So we're just going to put in test image. And then it's going to ask us how many images we want to process. So again, I had 32 images to run through. And so because of the restraints of my computer, has 32 gigs of RAM in it, it's a good computer, but MATLAB is somewhat memory intensive. I would sometimes break it down into sections where I might do 8 at a time. So here we only have one image we want to process for the sake of time, and then it's going to ask us the number of the first image we want to process, which of course is still 1. And then what the program does now is it gets the size of the image. And as you can see here, this is a pretty big image. If you were to do the math, you'd find that there were more than 4 million pixels in this image. This is important because the program goes pixel by pixel to analyze the image in order to obtain a value for porosity. Now, that's important because it takes a very long time to go through such a large image. So the program will give us an option to resize the image or keep it at its base dimensions. And so just to show what it looks like, I'm going to start with the base dimensions. And then it's going to give us 3 options. This program was initially 3 or 4 programs, and I combined them into one. And so here we get to decide what we want to do with it. So we can either start by checking sensitivity values, and I'll just quickly explain which of these functions does. If we were to choose, or if we were to check sensitivity values, what that does is it connects to an Excel spreadsheet. And in that Excel spreadsheet, it runs through all the possible values for our inputs. Our inputs are the same image. It keeps the same image for the run, and then it runs through a threshold value for the image. I'll describe that more in detail in a minute, from 1 to 255. So there's 255 rows in that Excel spreadsheet. I'll show it at the end. And it will run through every single one of those numbers and get the different values for the porosity. So what that means is this program is going to take the image, which I can show. It's going to take that image and it's going to check what values it gets for porosity when it increases or decreases a certain threshold value. And what that threshold value is it's basically saying how light or dark, what constitutes a pore. So when it breaks this image down into black and white, it's going to have to determine what's black and what's white. And in order to do that, it has to be able to tell what's a pore and what's not. So there's going to be a certain brightness value. I say it's a brightness value because that's what the program determines as a pore and what's not. And you'll see that at the end. So that threshold value can be anywhere from 1 to 255. I didn't know where to start because I was modeling it from a paper, but the paper did not give any sort of value. So in order to find the accurate or the threshold values that give us accurate numbers, I had to first run through all of them. So that's the first aspect of this program. I'm just going to go ahead and explain the other two, and then we'll go through each one. The second option is to generate images. So what this does, it will still create porosity and pore ratio values. This is the other variable that I was trying to obtain a value for. It's going to generate an image of the updated. It's going to generate an image that's very similar to this, but it's going to outline the pores in red, and that's so that we can see what the program decided was a pore and what wasn't. And in order to do that, it's going to require a threshold value. That's because it needs to be able to determine, make that distinction between what constitutes a pore and what doesn't. So that's the second one. And then the third option is to just obtain the porosity and pore aspect ratio data. Now, keep in mind that when we're running through this program, it's not going to actually spit out that data to the window here. I wasn't interested in that when I was working on this program. I was interested in obtaining information. So in order to obtain that information most easily for all 32 images, I would just send it straight to an Excel spreadsheet. So that's what the third option does, is it runs through a very similar process as the first two options, but it will just obtain that data. Because what I was doing was trying to get that information in the simplest and most cost-efficient manner possible. So that's the easiest way to get that information. Okay, so we're going to start with checking sensitivity values. And it's going to give me, it's going to require a range. So I'm going to start at, let's say, 52 out of 255. And then the final sensitivity value is the last value it's going to check. So it's going to be a range from 52 to 57. And so what it's going to do is it's going to run through all of these steps. And then once it's done, it uploads all that information to an Excel spreadsheet, which I will pull up now. That's important because, or something important to note, is that this Excel spreadsheet is cannot be open at the same time as the MATLAB program, or it won't be able to access it. Okay, so you can see, if I make this smaller, you can see over here on the side that it has generated porosity values for the sensitivity or threshold values from 52 to 57. So it will send those values directly to the Excel spreadsheet. And so that's the first usage. Now, let me go ahead and close this again. And then we're going to do the program once more. Again, we'll keep the base dimensions. And then we're just going to generate images for this one, and I'll be able to show the outline of the pores. Okay. We're going to again use, I believe we're going to use a value of 57 for a threshold value, sensitivity value. And once the program finishes, because again, it's running through 4 million pixels, it will take a minute. Once it finishes, it's going to generate an image that outlines the pores in the image that we've chosen. Okay, and so the program has now finished creating the images, and I'm going to slide this over, and we can see that this is the image that has been created. And as you can see here, with a sensitivity or threshold value of 57, these are the pores that the program has identified. You can see they're outlined in red. So it just gives a very nice visual explanation as to where those porosity values came from. And again, they're found in an Excel file that I created specifically for this purpose. And so you can see here, it is again actually generated porosity value. We also should have the same for this value, which you can see. It has generated a pore ratio value as well. Okay, so that is the second option. Now, for the third option, we're going to run the program again. Again, we're going to use the base dimensions. Then we're just going to obtain the porosity and pore aspect ratio data. Now, as a reminder, I need to go ahead and I'm going to clear the contents of this just to show what it looks like. I'm going to do the same over here. And then we're going to save and close out this Excel file because MATLAB cannot access it while the program is running. Now, we're going to we're going to use, let's just say a value of 35. That was actually rather fast because, again, it doesn't take much for the program to process that information. Now, we again have our value here for, this is going to be porosity, and then we go down to the same place for pore ratio. And you can see these values are different because there's uh, different threshold value. And we'll just change the column width. Now you can see. So the other thing I should mention is that you can see here that this is outlined in red, whereas the porosity value is outlined in green. Now I'm going to explain very briefly what that means. When I was running through this program, what I wanted to find was what were acceptable values for porosity and pore ratio. And in order to do that, the paper that I was using had listed some values that were consistent with other literature for porosity. So I use those values just as sort of a guide. I also use the images from their paper to guide my range, and I was able to implement something into Excel that will automatically label these red or green based on whether or not they're acceptable. So that's what the red and green means. Now, we can also do something similar with cropped images. And here, you can see that in the porosity and pore ratio, I have uncropped sheets over here, and then I also have cropped. So what we're going to do is we're going to again save this, and we're going to close it. And then we're going to repeat the same processes with the cropped images. And here we're going to input what value we want for the height. Now I believe what we have here is we have the height by width. And when I say cropped, I don't mean taking away any of the information from the image. I mean that we're going to resize the image to make it a different dimensions. So I believe we have here height by width. So we're going to put in maybe 1600 by 1600. And then we're just going to check sensitivity values again. And it's going to be from 52 to 57. And now we're going to go back to our Excel spreadsheet. We're going to open it up. We should see, as we close this, we should see values start appearing over here again. Yes, we have 52 to 57 has been filled in, and you can see we have different sheets. We go down here as well, and we have more values that have been filled in. And so it can apply to porosity and pore ratio again. Okay, so we're going to go through second option, and we're going to use the same size again as well. And then we're going to generate the images. Now let's go ahead and save and close out the Excel spreadsheet. We're going to use 57. This is going to take a minute. Even though the image is smaller, it's still going to take a minute for the program to process it. So we're going to fast forward again. Okay, and here we are again. We have our image that has been created. You can see it's square. You can also see that because it was not originally square, it's been slightly skewed, but the same purpose is achieved. So we can still see that the program has outlined in red the pores. And when I was testing the difference, for example, in the values, like you can see that the image was pretty similar to what we saw earlier, but the question comes up, does the cropping or the resizing rather of the image affect porosity to pore ratio values that much? And I found that it actually doesn't. They're pretty similar because it's still going over the same image. It's just been resized. But for the sake of accuracy, it is obviously better to use the base dimensions. Okay, so we're going to now go through the very last, and we will fast forward again. Again, we're using the same value for resizing the image, and then we're just going to obtain the data. Now, because we've already chosen 52 to 57, I want to show a different one. We're going to go to, let's say, 80. Let's try 80. Again, very quick because it does not require a lot of computation. And because this was cropped, it should be over here. Now, because it performed a separate calculation as you may remember, there was data in here. In order to keep that data, you would have to run you have to run the full program. So it will delete the data um, for that column. We can again go over to porosity, increase column width, and we can see here that for a sensitivity value of 80, it is again created porosity entry. Okay, so that is the extent of the program. I have not included specific checks on like height values, for example, or width values like a maximum, except for it does have to be greater than or equal to 100 pixels, because if you get much smaller than that, you kind of lose functionality. Um, but yeah, so that is the extent of this program. It is, I think, probably one of the best programs that I've created in MATLAB. There's more that can be done to it. So, but it does work. It works well for everything that I was want to use it for. It was a very exciting and interesting project for me to work on. I hope you enjoyed learning about it. And again, it is posted to GitHub. I have posted the link in the description. I hope that you have fun playing around with it and looking at how this program works more in detail, because this just explains how to use it. It doesn't explain any of this code up here, but the code has comments in it. It's relatively easy to understand what it's doing. And yeah, so I hope that you've enjoyed watching the video. Please do share if you're interested. Comment, ask questions. I'm happy to answer and excited to learn more about the additive manufacturing field. Thank you so much for watching. Please do have a wonderful rest of your day and a Merry Christmas.